All right, let's dive right in. Welcome to This Explainer, where today we're going to unpack one of the absolute most fascinating industrial pivots happening right now. We're talking about taking a completely common, everyday crop, one you probably only think about when you're stirring your morning coffee or grabbing a sweet treat, and turning it into an industrial powerhouse that could fundamentally replace petroleum-based plastics. We're going to dig into the science, the data, and the real-world market forces behind how sugarcane is being engineered to literally grow our next generation of packaging. Seriously, just think about that for a second. What if your next plastic water bottle or that little clamshell container holding your takeout was actually made out of grass? Because, well, technically speaking, that's exactly what sugarcane is. It's just a towering, incredibly fast-growing species of grass. I know, it sounds a bit like science fiction, but this isn't some distant prototype locked away in a lab. This transformation is happening right now at a massive industrial scale, and it's totally reshaping how we think about the life cycle of the products we use every single day. Section 1. The Global Plastic Crisis. Section 2. Sugarcane, the Unlikely Hero. Okay, so to really combat the 360 million tons of traditional plastic we're churning out every year, and the pretty harsh reality that only about 9% of that actually gets recycled, we need something powerful. Enter the sugarcane stalk. It's grown in over 100 countries around the world, and this simple little plant generates an estimated 700 million tons of byproduct globally every single year, mainly in massive agricultural hubs like Brazil and India. For decades, a lot of this was just looked at as waste. But today, spurred by huge regulatory shifts like the European Union's Single-Use Plastics Directive, it's become the raw material for an absolute packaging revolution. Section 3. Bagasse, Molding the Future. Our first technological pathway really taps into sugarcane's physical superpower, and it all starts with something called bagasse. So what exactly is bagasse? Basically, it's that rough, fibrous residue left over right after the sugarcane stalks get mechanically crushed to squeeze out their sweet juice. Because it's an agricultural byproduct, it doesn't need all this crazy, complex chemical extraction to be useful. I mean, we already crushed the cane to get the sugar, right? Now, we're just taking that leftover fiber, running it through some wet pressing and slurry molding, and turning it straight into plates, bowls, and takeout containers. And here is where it gets really good. This is its most vital characteristic. We all know traditional petroleum plastic just sits around in the environment for centuries. But molded bagasse, it's totally biodegradable. Whether it's in your home compost or an industrial facility, it breaks down in just 90 to 180 days. It naturally has structural integrity, it resists grease, and when you're done with it, it safely goes right back into the earth, practically vanishing in a matter of months. This perfectly highlights the two totally different directions we can go with sugarcane. It's basically a fork in the road. On one side, we have molded bagasse, that physical molding of agricultural waste that gives us a completely biodegradable product. But on the flip side, we have bioplastics. Now, this route uses chemical extraction. The bioplastic you get at the end isn't compostable. Instead, it is molecularly identical to standard plastic. That means it's super durable and can actually be recycled right alongside all your regular plastics. Section 4. Bioplastics. Chemistry going green. So let's look closer at that second superpower, Bio-PE, which stands for bio-based polyethylene. To put it in everyday terms, polyethylene is the plastic used for your grocery bags, flexible packaging, even kids' toys. Usually, the ethylene used to make all that comes straight from petroleum. But Bio-PE gives us the exact same material, chemically identical in every single way, with the exact same strength and flexibility, except it's derived entirely from a renewable biological source. The step-by-step process to pull this off is practically magic. Step 1, you harvest and mill the sugarcane. Step 2, and here's the clever part, instead of just taking the sugar, modern mills extract ethanol from the juices. Step 3, that bioethanol is catalytically dehydrated to produce ethylene. And finally, step 4, that ethylene is polymerized into Bio-PE resin. And because this final product is chemically identical to conventional plastic, manufacturers can use it as a drop-in solution. That means they don't even have to change out their existing factory machinery to start using it. Huge win. Section 5. Comparing the carbon footprint. But does this actually move the needle on global warming? Let's check out the math on global warming potential, or carbon footprint, which is measured in kilograms of CO2 equivalent per kilogram of material. Standard petro HDPE generates roughly a positive 1.9 to 3.1 kilograms of CO2 for every kilogram produced.
But look at the sugarcane alternatives. Molded bogus is sitting way down at a negative 3.50. Bio-PE is at a negative 2.12 to negative 3.10. Honestly, those minus signs are everything.
The contrast here is just wild. You've got this massive spike of emissions pouring into the atmosphere from traditional plastics. And then you have sugarcane products absolutely plummeting below the zero line into net negative territory. We aren't just talking about a material that is, slightly less bad for the environment. We are talking about a material that is actively reducing the carbon burden. So the real mind bender here is understanding how a manufactured product can possibly have a negative carbon footprint. The secret is wonderfully simple: photosynthesis. As the sugarcane grows out there in the fields, it captures massive amounts of CO2 from the air. A huge chunk of that captured CO2 gets locked directly into the bioethanol, which forms the basis of the plastic resin. Because of that, the final product sitting on the store shelf is literally storing more carbon dioxide than was emitted during its entire manufacturing process.
Section 6, building a circular economy.
So how does an industry scale this up globally without just creating a bunch of new ecological problems? The answer is a strict, nothing wasted philosophy. There's a really great quote from our sources that highlights how modern Brazilian sugarcane mills operate as integrated biorefineries. Basically, they produce sugar, they produce ethanol, and then they take those leftover bagasse fibers and actually burn them to create steam and electricity. That process completely powers the entire manufacturing plant. It's so efficient that they often generate excess renewable energy, which they then sell right back to the national grid. They even take the nutrient-rich wastewater from this whole process and send it back to the fields to fertilize the next crop.
To make sure this transition stays truly sustainable, industry experts have flagged a few key strategic innovations we should all be looking out for. First off, prioritizing those zero-waste integrated biorefineries we just talked about. Second, implementing PFAS-free barriers, so using natural additives to make sure our molded food containers resist water and oil without needing any of those toxic forever chemicals. Third, upgrading our recycling facilities with near-infrared, or NIR, sorting infrastructure, so these bioplastics can be cleanly separated and actually recycled. And finally, relying on really robust metrics like bond sucrose certification. That guarantees the sugarcane was sourced ethically without driving deforestation or violating fair labor practices. We have covered quite the journey today, from a simple green stalk growing in a field to a high-performance carbon-negative solution for a massive global crisis. The technology is already here, the chemistry completely works, and the infrastructure is scaling up right now. So I want to leave you with one final thought. If our packaging can literally grow from the earth, power its own production, and safely return to the soil, what are you going to choose for your next purchase? Thanks so much for joining me on this explainer, and I really encourage you to keep exploring the sustainable choices all around you.